Okay. When I divide by a, you get x squared as your first term, right? Then b over a x equals negative c over a. Are we okay there so far? Okay. Then your next step normally would be to take half of b, square it, and add it to both sides. Okay. I'm going to do that off on the side here. My b value is actually this fraction now, b divided by a. So I'm going to take half of that, which when you're multiplying fractions, you just multiply across on the top and the bottom, right? Okay. So you'd get b over 2a. Are we okay with that? And then normally you would do what at this point? Square it. And then would it be okay if I wrote that as b squared over 4a squared? Because I'm just squaring everything in that fraction. So we're going slow. So then we're going to add that to both sides. And this is why we do it, to show you this is why it's nice to have a quadratic formula. But I don't like to just give you formulas at this point in your math, like in Algebra 2, without at least showing you where it comes from. Okay. Now, in a normal problem, when we get to this point, we usually factor the left side. Now, this is where the pattern that we've kind of caught on to is helpful, because whatever half of b was, that's what goes in the parentheses when we factor, right? So what was half of b? B over 2a. So b over 2a is what's going to go in the parentheses. So we have x plus b over 2a. So when I factor that left side, you end up getting that. And then when I add these two fractions together, with any fractions, don't you need common denominators? So we have an a here, and we have 4a squared here. So how many more a's do I need on the bottom here? Well, I need a 4, and I need one more a to make it a squared, right? So I'm going to multiply this one by 4a over 4a. Again, right now I'm getting common denominators. It is, yeah. So can someone tell me what I have on the top here if I multiply all three of those together? 4ac over 4a squared, right? Oh, sorry, negative, yes, good. Negative 4ac. And then right here I have still b squared over 4a squared. Okay, now I'm going to add the tops together now that I have common denominators, and I'm going to flip the order, because when we get to the quadratic formula, you'll notice that they're flipped anyway. So before I take the square root of both sides, is it alright if I do this? So I'm adding across on the top, and I just switch the order. So you're just adding those two together, but then I put the b squared first. Okay, we're almost actually done. Now, when you get to this step in a normal problem, you would do what to both sides? Take the square root of both sides. And when I take the square root of the left-hand side, you should be following. Hold on. When I take the square root of the left side, what happens to the square? They cancel, right? You know the x plus b over 2a? And then when I take the square root of the right, the top is going to say the b or square root of b squared minus 4ac, but can I take the square root of the bottom? Well, can I take the square root of 4? 2, and then the square root of a squared is just a, so it'll just be 2a. And then we're going to subtract b over 2a from both sides, right? Yes? done here. And do I have common denominators? So, x equals... Oh. Yep, I have common denominators. It's nice that it worked out that way. So I have negative b plus or minus. And sorry, I forgot to add that because when you take the square root of both sides, you have the plus or minus there. Square root of b squared minus 4ac all over 2a. Does that look familiar? Yeah. It should look familiar. Nice. Hold on, I've seen this before. What is it called? The quadratic formula. Yeah. So this is where it came from, though, is by completing the square on the standard form. That is amazing. Kim, yeah. No, what, Kim? Yeah, it's really good. Oh, one of the chairs is speaking? Yeah. Didn't know we had a name for it. Alright. Get out your notes. So you might want to keep track of this page if you want to take advantage of that extra credit opportunity. Yeah. I'll get you one. No, I said keep it. I will ask you to do the same thing. Like I'll say solve this. When? When we get closer to the test. Oh, the cheat sheet? She actually likes to find out like everything. Yeah, that's how much shit. And then if you sign it, then it's extra credit. And then because I I'll make another copy. Not yet, but I will. I'll put it on there today. Okay. In your notes. I said my sub. Cam. You need another little hallway talk? Alright. The quadratic formula. Well, first, before we write down what we just had on our piece of paper, the reason the quadratic formula is nice and why it works is because you basically complete the square for any type of problem, and in the quadratic formula, all you need are the a, the b, and the c values to plug in. So when you have decimals or fractions or anything like that, the quadratic formula is nice because this gives us another option to solve any quadratic equation. Circular. Because this allows you to solve anything. So if factoring doesn't work, or completing the square is too complicated because it has a bunch of fractions, then the quadratic formula is where you need to head. So, quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. I will not put this on the test. You do have to have it memorized. But if you write down this formula every single time you do a problem for the next couple days that we're working on it, you will have it memorized after writing it down. So we're going to write it down every time before we just start plugging numbers in. Yes. Alright, a couple of notes that we need to write down. First thing, we need to make sure that we write the quadratic equation in standard form. So that's ax squared plus bx plus c. Because normally when we solve anything, we have to get it equal to 0. And if you don't get it in standard form, meaning everything on one side, you're going to have one of your values be wrong. Like your a, your b, and c won't be totally correct. The solutions you get can be 1 or 2 real numbers. You can get 2 imaginary numbers. So let's talk through some of these options, and you guys actually do know the answers to these already. If you get 2 real numbers, let's say you get -1 and 4 as your answers. The graph has 2 what? x-intercepts. When you get two real answers, that means on the graph you have two x-intercepts. What if we get just one answer?
The vertex.
The vertex. Good. So the graph has a vertex on the x-axis. That can be helpful to know in some cases. And then if you get two imaginary numbers, the graph has no x-intercepts. Because can you plot imaginary numbers on the number line? No. So the graph has no x-intercepts.
Yeah, you have to use your imagination.
Yeah. Is it possible to have a quadratic graph that has no x-intercepts?
Maybe.
Wouldn't that one have no x-intercepts? Yeah, that one wouldn't. So yeah, it is possible. All right. Go to example 1. Let's start with 2x squared minus 3x plus 7 equals 0. Alright, now let's think through our options. Let's pretend I didn't tell you we're going to solve this using the quadratic equation. The first way that you learned how to solve was by factoring. And so if we were to factor, you start by multiplying the a and the c together. You get what? 14. Are there two numbers that multiply to get 14 and add to get negative 3?
No.
Okay, so factoring's out. Then let's think about completing the square. We move that over, and then we'd have to divide by 2. So you get 3 halves in the middle, and then you'd have to take half of that and square it. You'd have a bunch of fractions working, right? Yeah. Okay. So that's why quadratic equation or the quadratic formula is nice, because it eliminates some of those problems. So before we actually start plugging stuff in, I actually like us to plot the a, the b, and the c and write them off on the side, because then you don't have to keep looking back at the equation. Oh, sorry. First of all, you have to make sure this is in standard form. Is it? Yeah. If it's not, you have to get it in standard form. It is. So then we're going to label what the a, the b, and the c are. Jake, can you give me what the a value is? 2. The b value is? C value is? And on that note, Kirsten, you're out of here.
Go, Tom, go.
After that mayhem,